Session is being recorded. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will explain lab number 2 in the mobile and wireless networks course. So basically this course is about mobile and wireless networks, and we have reached lab number 2, which is about radio frequency power calculations, RF power calculations. What are the learning objectives? We will learn how to convert radio frequency power from watt and milliwatt to dB and dBm. So we will learn how to calculate the effective isotropic radiated power, EIRP, at the transmitter side, here, at the transmitter side. And we will learn how to calculate the received power at the receiver side. So the signal, it is transmitted from the transmitter. It passes through the cable where I have losses. Then it passes through the antenna where I have gain. Then it propagates in the free space between the transmitter and the receiver. At the receiver, I have gain for the receiver antenna. Then I have loss for the receiver cable. Then I need to calculate the signal power at the receiver. This lab is about 2 parts. The first part is about radio frequency and logarithm rules. So as a radio frequency signal propagates away from a transmitter, the power density reduces. كلمة signal ينعمل propagation من الترانسميتر باتجاه الريسيفر، الباور تاعت السيجنال هتضعف. So the signal power will be reduced as it becomes far from the transmitter. It reduces, conserving the power in the electromagnetic wave. In the absence of obstacles, there is no obstacles between transmitter and receiver, and with atmospheric attenuation, the total power received at the receiver is equal to the power transmitted. So if I don't have obstacles, I don't have atmospheric attenuation between the transmitter and the receiver, the total power received at the receiver will be equal to the power transmitted. But in reality, I have atmospheric attenuation between transmitter and receiver, and I have obstacles between transmitter and receiver. So this is ideal case, this is not real case. Okay? Let us learn about logarithm rules before converting from watt to decibel and from decibel to watt. In the logarithm rules, as we have studied, there is a multiplication rule. Log of x times y equal log x plus log y. For sure, this log to the base a. In our case, in the wireless communications, we are interested in the base 10, log 10. In binary and computer science, you have studied log 2. And other material courses, you have studied log e, log to the base e. So in this course, we are interested in the log to the base 10. But this formula will apply to all. It will apply to log base 10, log base 2, log base e, etc. So for this reason, he wrote a. Okay, but we are interested in log to the base 10. So log of x times y equal log x plus log y. Division rule, log of x divided by y equal log x minus log y. So if I have, for example, log 6, I can write it log 2 times 3, which is log 2 plus log 3. If I have log 6 divided by 2, it is equal to the log 6 minus log 2. Exponentiation rule, and this you will need it a lot, log x to the power n equal n log x. So log 10 to the power 2 equal 2 log 10. Log 10 to the power 3 equal 3 log 10. And log 10 always equal 1, which equals to 3. We will give examples about it. Log 1000 is log 10 to the power 3, which equals 3 log 10. which equals 3 because log 10 always equal 1. So the term decibel, the term dB is an abbreviation of decibel. When we say dB, we mean decibel, okay? Which is equal to the 1/10, 0.1 of a bell, named after Alexander Graham Bell. So هذا اسمه بالزلمة Alexander Graham Bell. Okay? فعم بحكي لكم he's telling us from where this term came, decibel. هذا اليونت, this unit from where it came. It was equal to 1/10 of a bell, which is the name of a person, Alexander Graham Bell. So the unit bell used to represent very small quantities is a logarithmic measure of the ratio between two quantities. So this is explaining the dB from where it came. This is يعني theoretical background. So the dB, which is the decibel, is used to represent a variety of parameters in different fields or in various fields, such as acoustics and electronics. Here, in this lab, we will use the dB for measuring the signal power to check the difference between power 2 and power 1, as we will see in this example, in this lab. So power in dB is represented by the following equation, where P0 is the reference power. So basically, I am finding the difference between power P and power 0. Power 0 is the reference. So how much power P is greater than power 0? قديش باور P أعلى من باور 0 بالدي بي؟ I know power P in watt. I know the value of power 0 in watt. But how much power P is higher than power 0 in decibel? So to calculate this, I will use this formula. Power in decibel equals 10 log ratio of power P divided by reference power 0. So I will give you the power P in watt, and I will give you the reference power in watt, and you will calculate the power in dB, which equals 10 log P divided by P0. So if both are in watt, if both powers are in watt, I will get the result in dB. If both powers are in milliwatt, also I will get the value in dB. So when I will get dBm, I will get the power in dBm when the reference power is 1 milliwatt. If the reference power is 1 milliwatt, I will get the value here in dBm, not in dB. Okay? The logarithm is base 10, log to the base 10. So when converting to dBm, decibels reference to 1 milliwatt. يعني P0 بتساوي 1 milliwatt. P0 will equal 1 milliwatt. This is the power in dBm. 10 log to the base 10. P milliwatt divided 1 milliwatt. Thus 1 milliwatt of power is used to 0 dBm. Okay? The unit dB كله بعده هيدا, all this is theory. Still we did not start the practical lab. So the unit dB can also be used to represent absolute power value by defining a reference power and adding the corresponding suffix to dB. For example, dBm stands for dB with reference to 1 milliwatt. هون عم برجع يعدل لكم انه امتين بيكون عندي dBm 1, I will get dBm 1, I will get dBm here when the reference power is 1 milliwatt. طب let us start by task 1. Task 1. Complete the missing values in table 1. Convert milliwatt to dBm. يعني he gave me the power in milliwatt and I need to convert it to dBm. I have the power in milliwatt, I need to convert it in dBm, and the opposite. I have the power in dBm, I need to convert it to milliwatt. So we will work this table. Okay? We will work this table. So to convert from milliwatt to dBm, I will use this formula. I have the power in milliwatt. I will calculate the power in dBm. And to convert from dBm to milliwatt, I will use this formula. I have the power in dBm. I will divide it by 10. I will divide it by 10. Then I will take 10 to the power, the value that I got here. I will calculate the power in milliwatt. So let us start. Here he gave me one example. So I will apply both formulas. Okay? For this is given. These values are given. How many milliwatt I have here? 0.000001. Or basically 10 to the power minus 5. I will use this formula to get the power in dBm. I will use the calculator because this is your first lab, so you can use the calculator. 0.1234, 4 zeros, 1. I will take the log to the 10 power minus 5 equal minus 5 log 10. Let me write it for you. What happened here? What happened here? He took the log of 0.12341. This equals log to the 10 power minus 5. Log to the 10 power minus 5, which equals minus 5 log of 10, because log x power n equal minus n log x. Log x power n, this is the formula. Log x power n equal n log x. So log 10 power minus 5 equal minus 5 log 10. And log 10, how much does it equal? 1. Log 10 always equals 1, which equals to 5. Okay? So here, when I calculated the log of 0.00001, the result was 5. Times 10, because I have 10 log P in milliwatt, times 10 equal minus 50. Let us do the opposite. I'll start by minus 50 and I will use this equation. Okay? So minus 50 dBm minus 50 dBm divided by 10 minus 5. Okay. 10 power minus 5, 10 power minus 5 equals 0.00001. So I need to apply these two formulas only to convert from milliwatt to dBm and from dBm to milliwatt. Let us do this one. 0.0001. 0.0001 log. How much does it equal? Minus 4 times 10. So the result is minus 40. Minus 40. Okay? Minus 40. And this, you can see it here. Let us do it in Microsoft Word, step by step. I'll copy and paste this one, and I will remove 1 0 here. Log of 0.0001. is equal to log 10 power minus 4 is equal to minus 4 log 10 is equal to minus 4. For sure, here I have 10 log, 10 times log. At the end, 10 times log, 10 times log. So this will equal minus 50. Okay? And here I have 10 times log. 10 times log to the 10 power minus 4, which equal minus 40. Okay? So let us do this one. Minus 30. Minus 30 dBm. I need to get the value in watt, in milliwatt. Okay? So I will use this formula. Minus 30 divided by 10. Minus 30 divided by 10. How much? 3. 10 power minus 3. 10. 10 power minus 10 power minus 3. Oh, I put a 0 by mistake. I'll repeat. Minus 30 divided by 10 equal minus 3. Okay. 10 power minus 3 equals 0.001. Equal 0.001. Okay. So let us do this one. 0.001. How much in dB? He gave me this number as given, but I will calculate it. 0.001 log 0.01. 0.01 log, I'll take the log times 10, which equals minus 20. I'll do the opposite. I'll use this formula to convert from dBm to milliwatt. Minus 20 divided by 10 equals minus 2. 10 power minus 2, 0.01. Okay. Let us do this one. Minus 10. Minus 10. Okay. Minus 10. So I have the dBm and I need to convert it to milliwatt. Calculator, I'll use the calculator. Minus 10 divided by a dash by how much? Divided by 10 equal minus 1. I will take 10 power this value, 10 power minus 1 equals 0.1. Okay. Now 3. Let us do the 3. Oh, there is before 3 there is. Okay, let us do 3. I will do this before dBm. Top. 1 milliwatt. 1 milliwatt. How much in dBm? I'll use the calculator. 1 milliwatt. I will take the log. Log 1 is always 0. We have mentioned this in the lecture. Log 1 is always 0. Times 10 equals 0. So basically, log 1 is always 0. log 1 is always 0. And log 10 is always equals to 1. So log of 10 equal to 1 always. Log of 1 always equal 0. Okay, let us continue. I have the value of power 10 in milliwatt. I need to find it in dBm. Okay, I have 10 in milliwatt. I need to find it in dBm. I'll take the calculator. 10 log of 10. How much? 1 times 10 equals 10. So this will equal to 10. 10 in milliwatt equals 10 in dBm. This is easy. 10 in milliwatt equals 10 in dBm. But what about 100? 100 log 100 log of 100 equal 2 times 10, it will equal 20. How is this calculated? Let me do it for you in Word. 10 log 100, okay, equals 10 log 10 to the power 2. 10 log 100 equal 10 log 10 power 2 equal 10 times 2 log 10, because log of x power n equal x log n equal 20 log 10. And how much this is equal? Log 10 always equal 1, which equals to 20. And this is what is calculated here. Log of 100, 10 log of 100 equals 20. So if the power in milliwatt is 100, and dBm it will equal 20. And what about 23? If the power in dBm is 23, how much it is in watt? This is very important because I will calculate it in two ways. If the power in dBm is 23, how much it is in milliwatt? 23 divided by 10, 2.3. I will take 10 power. 10 power 2.3 equal around 200. So this will equal 200. Can I calculate this in another easy way? Yes. Yes. Okay. I will tell you. If 20 dB gave me 100 milliwatt, right? 20 dB here, we calculated that it is 100 milliwatt. 100 milliwatt equals 20 dBm. So, how much is 23 dBm? We have learned in the lecture the rule of 3. Rule of 3, it is here. Any increase of 3 dB, of 3 in dB, it means the power is doubled in decibel. The power is doubled in decibel. If P2 is higher than P1 by 3 dB, that means P2 equal to P1. So any increase of 3 dB, and that means the power is doubled in watt. And the opposite, if the power is doubled in watt, this means that I increase the 3 dB in decibel. So 20 will give me 100 milliwatt times 2. Why times 2? Because this 23 is a 20 plus 3. 20 dBm plus 3 dBm. So if 20 dBm will give me 100 milliwatt, the addition of 3 dBm, the addition of 3 in dBm means multiplication of 2 in watt, which equals 200 milliwatt. And this is the value that I got when I used the calculator, 200 milliwatt. Now 400. First, I will use the calculator. Okay. 400 in milliwatt. I will take the log of 400, 2.6 times 10, 26. So log, if the power is 400 milliwatt, and dBm it is 26. But can I solve it analytically? Let us solve it together. 200 milliwatt gave me 23 dBm. 400 milliwatt, how much it will give me? 23 dBm plus, how much I multiplied here? By 2. I multiplied 200 by 2. Okay, so I will increase in dB how much? 3 dBm, which equals 26 dBm. Okay, 23 dBm. 1000 in milliwatt, how much in dBm? This is easy. 1000 log of 1000, how much? 3 times 10, it equals 30. Let us solve it together. Log of 1000 equal 10 log 10 power 3 equal 10 times 3 log 10 equal 30 log 10 equal 30 dBm. This is what I calculated here, 30 dBm. So this is task number one. Okay, so this is part one. This is part one of the lab, and task number one. Now I have task number two. Task number two is about what? Complete the missing values in table 2. What's to dB conversion? So task number one is to convert from milliwatt to dBm and from dBm to milliwatt. Task number two is to convert from watt to dB and from dB to watt. I will use the same formulas, but instead of milliwatt here, I will write dB. I will write watt. Instead of using milliwatt, I will write watt. And instead of writing dBm, I will write dB. So this became watt and this became dB. Here also the same formula. Instead of writing dBm, I will write dB. And here, instead of writing milliwatt, I will write watt. So it is similar process. Let us do it together. Okay? Let us do it together. Let us start. 0.001. If the power in watt is 0.001, how much does it equal in dB? We'll take the calculator. 0.001. I will take the log. Log of 0.001 equals minus 3 times 10. This will equal minus 30. Minus 30 dB. If the power in dB is minus 20, how much is it in watt? I will take minus 20 and I will divide by 10. Minus 20 divided by 10. How much? Minus 2. I will take 10 power minus 2. 10 power minus 2 equals 0.01. Similarly for minus 10. Minus 10 divided by 10. Minus 10 divided by 10. How much? Minus 1. 10 power minus 1 equals 0.1. 0. 1 dB is 0. When I have 0 dB, how much does it equal in watt? Does 0 dB equal 0 in watt? Or equal 1? Or what does it equal? Let us calculate. 0 in dB divided by 10. 0 divided by 10 is 0. 0 divided by anything is 0. 10 power 0 equal 1. 10 power 0, anything power 0 equal 1. Anything power 0 equal 1. So 10 power 0 equals 1. Yalla, let us calculate. 3 in dB, how much does it equal in watt? 3 divided by 10, 0.3. 10 power 0.3, it equals 2. So here I have 0 dB, I got 1 in watt. Please focus on this. Here I have 0 in dB, how much does it equal? 1 in watts. I added the 3. If I added the 3 in dB, this means I double the value on watt. I will multiply it by 2. I will double the value on watt. So I will multiply 1 by 2. It equals 2. So you can calculate it like this. If you added the 3 in dB, you will multiply by 2 in watt. This is based on the 3 dB rule, law of threes. If you added the 3 in dB, you will multiply by 2 in watt. Here we have added the 3 in dB, right? So we'll multiply 1 by 2. Okay? Here I have given, this is given, 5 in watts equals 7 in dB. Let us calculate it. 5 in watt, I will take the log, times 10 equals 7 in dB, correct. 7 in dB divided by 10 equals 0.7. I will take 10 power 0.7, it equals 5. So it is correct. Let us calculate this one. 10 in dB. How much does it equal in watt? We have calculated minus 10. How much we got in watt? 0.1. So minus 10 dB equals 0.1. 10 dB, how much does it equal? Let us calculate. 10 in dB divided by 10. How much? 1. 10 power 1 equals 10. Equals 10. So minus 10 in dB equals 0.1. 10 in dB equals 10. Minus 20 in dB equals 0.01. Minus 30 in dB equals 0.001. 20 in dB, how much? Although it is not here, but I want to calculate it. 20 in dB divided by 10. 10 power equals 2. 10 power 2, 100. So 20 in dB equals 100 in watts. 16. 16 in watt, how much in dB? 16 in watt. I will take the log of 16 times 10 equal 12. Equal 12 in dB. 25 in watt, how much in dB? 25. Log of 25 equal 1.4 times 10 equals 14. Let us do the same for 27. 27. Log of 27, how much? 1.43 times 10, 14.3. I will repeat it. 27. Log of 27 equals 1.43 times 10 equals 14.3. طب 31. 31 in what? How much does it equal in dB? 31 in what? I will take the log of 31, 1.49 times 10, around 15. 15 in dB. 36 in what? How much in dB? I will take the log of 36 and I will multiply by 10, which equal 15.56. 43. I will take also the log of 43. Similar process. I will take the log of 43 and I will multiply by 10, which equals 16.33. 50. 50, this is beautiful. I will calculate it in two ways. I can use the calculator and I will calculate it manually based on the law of 2 and law of 10. Let us start. 50, log of 50 equals 1.7 times 10 equals 17. Can I calculate it manually? Can I calculate it in another way? Yes. Yes. Let us see. Log of 100, how much? If I have 100 and what? If I have 100 and what? How much does it equal in dB? 10 log of 100, what? This is what here? Equal 10 log of 10 power 2 equal 10 times 2 log 10 equal 20 log 10. Log 10 equals 1 equal 20. So 100 watts, how much it gave me? 20 dB. 20 in dB. 50 watt. How much does it give me in dB? I divided by 2, right? I divided 100 by how much? By 2. I'll come to the rule of 2. If you divide into in what? You subtract 3 in dB. So here I divided by 2 and what? I will subtract 3 in dB. 20 minus 3, 17. So I will get 17 dB. So this is beautiful. You can easily solve it. If 100 will give you 20, if 100 will give you 20, automatically you should know that 50 will give you 17. How much 50 will give you? 17. 72. I calculated 36, right? 36 times 2, 36 times 2 equals 72. If you multiply by 2 and what? You add 3 in dB, which should equal 18.56. Let us calculate it. 72 log of 72. How much? 1.857 times 10 equal 18.57. So this is approximation. If you multiply by 2 and what? You will add 3 in dB. 77, let us take 77 in what? How much in dB? I will take a log of 77 and I will multiply by 10, which is 18.87, 18.86. 86 and what? How much is it in dB? I will take the log of 86 times 10 equal 19.34. Okay, Now the opposite. I have a 20 in dB. How much is it in watt? 20 in dB, how much does it equal in watt? I will use the second formula, this one. 20 divided by 10 equal 2. 10 power 2, 100. So 20 in dB equal 100 in watt. Now, if a 20 gave me 100, 20 dB gave me 100 watt. 26, how much it will give me? Let me write it here. If a 20 dB gave me 100 watts, 26 dB, how much it will give in watt? 26, it is 20 plus 3 plus 3, which means in watt? 100 times 2 times 2, which equals 400 watts. Let us calculate it in calculator. 26, I'll use the second formula, divided by 10, and I will take 10 power 26 equal 398, around 400. Around 400. Okay. 30 in dB, how much in watt? 30 divided by 10, how much does it equal? 3. 30 divided by 10 equals 3. 10 power 3, 1000. So this will equal 1000. Okay. So here I increased 10 in dB. From 20 to 30, how much did I increase? 10, which means I multiply by 10 here, based on the tens law of tens. If you add 10 in dB, you multiply by 10 in watt. So 20 dB give me 100 watt. How much 30 dB will give me? 30 is 20 plus 10. If you add 10 in dB, you multiply by 10 in watts, which equal 1000 watts. If you add 10 in dB, you need to multiply by 10 in watts, which equal 1000 watt. Okay? So this is part 1, which is about how to convert from dB and dBm to watt and milliwatt, and the opposite. This is lab 1, lab 2, sorry. Part 1, we solve 2 tasks in it. So in part 1, we solve 2 tasks. Let us come to part 2. Part 2 is the about EIRP, and it is about EIRP and to calculate the signal power at the receiver. Okay. First, we will start by theoretical explanation. What is antenna gain? The gain of antenna is always measured in dBi. Why in dBi? Why we say I? Because I, it refers to the isotropic antenna. So, which means the power gain of antenna compared to an isotropic antenna, with reference to an isotropic antenna, as we have explained in the lecture. What is an isotropic antenna? Isotropic antenna is an ideal, it's a theoretical antenna. It does not exist in reality, but it is a spherical shape. Isotropic antenna. Isotropic antenna. Isotropic antenna. This is spherical shape. It radiates power in all directions. It radiates power in all directions. So this is a spherical shape. It radiates power in all directions equally. So it does not have a specific direction. Its radiation is uniform in all directions. So for this reason, the power of this antenna is 0. And this antenna is theoretical, it is not ideal. It spreads energy in all directions in a sphere with equal power, which is not possible to design in practice. Its value is 0 dB. So the gain of any antenna is specified in dBi, which means compared to the isotropic antenna. In comparison to the isotropic antenna, because the isotropic antenna has 0 dB. طب, this is first term is antenna gain. Second term, free space propagation. What do we mean by free space? Radio frequency propagation. What do we mean by free space? The radio frequency signals emitted or transmitted by an antenna go through significant attenuation, even in the free space. What do I mean by free space? There is no obstruction or obstacle between the transmitter and the receiver. I don't have a blockage or obstacle or obstruction between the transmitter and the receiver. There is path, free space. But for sure, even if I have free space with no obstacles, there is attenuation for the signal. The signal will attenuate, يعني هتضعف. It will not remain the same before it reaches the receiver. So, what is attenuation? Radio frequency attenuation. So, in practice, a radio signal may encounter many objects in its transmission path. Usually, it encounters many objects, many obstacles. And even if it is in a free space where I have no obstacles, it undergoes attenuation depending on the absorption characteristic of the objects. There is attenuation. السيجنال هتضعف مع مرور الوقت أول ما توصل على الريسيفر. Similar to the free space propagation loss, higher frequencies attenuate much faster than lower frequencies. Higher frequencies like 5 GHz, it attenuates more than 2.4 GHz. Okay, so 5 GHz is higher frequency than 2.4 GHz. But when I say higher frequency, it means faster. The signal is faster, but wavelength is smaller. Wavelength is smaller. We mentioned last time that C equal lambda F. C equal lambda F. Okay. I have shown you that C equal lambda times F. C is the speed of light. C is the speed of electromagnetic wave. It is the speed of light. It is the speed of electromagnetic wave. Okay? In a free space. So the speed of light equals the speed of electromagnetic wave in a free space. How much does it equal? 3 times 10 power 8. This is constant. So C equals lambda times frequency, which is mentioned here as V. We call it F. As the frequency increases, the wavelength decreases because C is constant. And the opposite, as lambda increases, as the wavelength increases, the frequency decreases. Lambda, it is defined as the physical distance between two peaks. Okay? So C is constant, it is equal lambda F. The speed of electromagnetic waves being propagated is constant. Once I increase the frequency, wavelength will be smaller. Once I decrease the frequency, the wavelength will be larger. So here, what he is saying, 5 GHz has higher frequency than 2.4 GHz. Okay, when the frequency is higher, the signal is faster, the data rate is higher, but the coverage is less. The coverage is smaller. So here, 2.4, the signal is slower than here, but the coverage is larger. It has more coverage. Why? Because the wavelength is bigger. It has a larger wavelength lambda than this one. As the frequency increases, lambda decreases, wavelength decreases. So 5 gigahertz has lower wavelength, smaller wavelength, lambda compared to 2.4. So if you are sitting at home, for example, and you are connecting to the wireless, if you are sitting in your place near to the router, it's better to connect to 5 gigahertz because you will get a faster internet, faster speed. But if you are roaming in the home and moving away from the router, it's better to connect to 2.4 gigahertz because it gives you more coverage, higher coverage. Here the wavelength is larger, is bigger than the case of 5 gigahertz. Here it is faster internet, but it is suitable if you are fixed in your place and sitting close to the router. If you are moving away, this has higher coverage. Okay? Noise. The noise at the receiver consists of the thermal noise and the noise figure of the receiver. So a noise, usually it is around minus 174 dBm per hertz. Let us speak about receiver sensitivity. This is receiver sensitivity is حساسية الريسيفر. الحساسية عند الريسيفر. The receiver sensitivity يعني حساسية الريسيفر ده حتى يلتقط السيجنال. It is the minimum power required at the receiver for reliable detection of the signal. What is the minimum power required for the receiver to detect the signal reliably in a reliable way? This is called receiver sensitivity. It is the minimum power required at the receiver to detect the signal. Link budget analysis. Here we will start talking about EIRP and the received power at the receiver, received signal power at the receiver. Okay, let us start by an example. I will remind you by the rules. First, the EIRP is measured as the transmitter. Okay, it equals the transmitter power, which is 20 dBm, minus the cable loss plus the antenna gain. So it equals the transmitter power minus the cable loss plus the antenna gain. This is the effective isotropic radiated power. Effective isotropic radiated power equals the transmitter power minus cable loss plus antenna gain. The received power at the receiver equal to the EIRP, which is the transmitter power minus signal loss plus antenna gain, EIRP, minus the free space path loss, the path loss between transmitter and receiver, plus the antenna gain at the receiver, minus the cable loss at the receiver. There is also minus the cable loss at the receiver. Okay, minus cable loss at the receiver. So it is EIRP, which consists of transmitter power minus cable loss at the transmitter plus antenna gain at the transmitter, minus the free space path loss plus the antenna gain at the receiver minus the cable loss at the receiver. Then I will calculate the received power of the signal at the receiver. I can easily calculate it. Let us start. This is lab task number 3. Okay. Given a scenario, I'll use this block diagram. Okay. Given a scenario with a transmitter and a receiver that are separated by some distance, there is distance between the transmitter antenna and the receiver antenna. The transmitter uses an absolute power of 30 dBm. What is the value of the transmitter antenna? Antenna at the transmitter equals transmitter equal 20 dBm. 30 dBm. 30 dBm. A cable connects to the transmitter to its antenna. The receiver has a cable also connecting to its antenna. So I have cable from the transmitter side and I have cable from the receiver side. Each cable has a loss of 3 dB. Transmitter cable loss equal minus 3 dB. Okay. Receiver cable loss equal minus 3 dB. The transmitting and receiving antenna has gain of 10 dBi. So transmitter antenna gain equal 10 dBi. And the receiver antenna gain also it is 10 dBi. Okay. So I have both cable losses minus 3 dB here. This cable loss and this cable loss. I have both gains of the antennas is 10 dB, and I have the antenna power is 30 dBm. Okay. I need to calculate the EIRP first. The EIRP is at the transmitter side, right? EIRP equals transmitter antenna gain 30 dBm minus cable loss 3 dB plus 10 dBi antenna gain, which equals 37 dB. Thirty-seven. dBm. This is dB. 37 dBm. Okay. I'm using the unit of the transmitter antenna because this is dB. This is a ratio. Okay, this is a ratio. These are ratios. So if the transmitter power is in dBm, the EIRP is measured in dBm. So it is transmitter antenna power minus cable loss. Cable loss is 3 dB minus cable loss plus transmitter antenna gain, which equals to 37 dBm. How much is the received power at the receiver? The received power at the receiver equals the EIRP minus the path loss between the transmitter and the receiver. How much is the path loss? 90 dB minus 90 dB. So I will write it as it is first, path loss plus receiver antenna gain minus receiver cable loss. Okay, minus receiver cable loss, which equals EIRP how much? 37 dBm minus 90 dB. Path loss is 90 dB plus how much is the antenna gain? Receiver antenna gain 10 dBi. 10 dBi minus how much is the receiver cable loss? 3 dB. 3 dB. Okay. How much does it equal in total? 37 plus 10, 47 minus 3, 44 minus 90 dB equals minus 46 dBm. Okay, so it's a matter of addition and subtraction. 37 minus 90 minus 54 plus 10 minus 44. 37 minus 90, which is minus 53, plus 10 minus 54, minus 43, minus 3 equals minus 46 dBm. So it's a matter of addition and subtraction. Minus 37 minus 90 plus 10 minus 3. Thirty-seven minus 90 plus 10 minus 3, which equals minus 46 dBm. This is the received power of the signal at the receiver. And by this, we will end lab number 2. If in the mobile and wireless networks course, if you have any question, please don't hesitate to send me email at muhammadjshihab@gmail.com. Okay. Assalamu alaikum wa rahmatullah.